Hey guys, now we're going to solve for homogeneous differential equation. Now there are a few things that we must remember when solving this kind of problems. First, we have to reequate the equation to its standard form, which is the function m of xy dx plus the function n of xy dy, and is equated by 0. By doing this, we can identify the function m from the function n, which will be our basis on which case we're going to use in order to solve for our answer. So if m is simpler than the function n, all the variable x will change to vy, all dx will change to vdy plus ydv, and in later processes, the variable v will be changed to x over y. Now, the same thing happens when the function n is simpler than the function m. The only difference is that instead of the x variables, all the y variables will be changed to vx, dy will be changed to xdv plus vdx, and in later processes again, v will be changed to y over x. So this is the problem that we're gonna solve today. X dy minus y dx equals to xy 1 half dx. So as we discussed earlier, we cannot solve this homogeneous equation unless we transform it into its standard form of m of xy plus the function n of xy, and is equated by 0. So by transforming this equation, it'll become negative xy 1 half minus dx minus y dx plus x dy equals to 0. So as we observed, this become its own standard form. So we have to identify which case we're going to use. Since n is simpler in this equation, so all the variable y all the variable y will become vx, as well as all the variable dy will become vdx plus xdv, and on later processes the variable v will become y over x. And now that we've set the standard on how we're going to solve this homogeneous equation, we can now proceed with our solution. So negative xy will be transformed into negative x multiplied to x vx 1 half dx minus vx dx plus x multiplied by vdx plus x dv equals to 0. So now we're going to equate all the values. So negative vx squared 1 half dx minus vx dx plus vx dx plus x squared dv equals to 0. Now we cancel. Now negative vx dx plus vx dx is cancelable. So the remaining value will be negative v1 half dx, negative d1 half x dx plus x squared dv. Now we need to get rid of all the excess, so we'll factor them out on both sides by 1 over x. So the resulting value will become v1 half dx plus x dv equals to 0. Now, after getting this equation, we can now use the separable as a method on getting our answers on a more easier scale. So negative 1 half dx plus x dv equals to 0 will be then separated into y and x variables in order for us to solve for our answer. So x dv equals to v 1 half dx dv over v 1 half equals to dx over x. Now we've separated them, we can now integrate both sides. So the integration of dv over v1 half is the integral of sorry, it is v negative 1 half plus 1 over negative 1 half plus 1 equals to the integration of dx over x, which is ln x, and we're going to add the arbitrary constant, which is c, in order for it to become a separable equation. So now that we've established this, we're going to simplify in order to get our exact answer. So v negative 1 half plus 1 over v negative 1 half plus 1 will become v 1 half over 1 half equals to ln x plus the arbitrary constant, which is c. So we can further simplify this. 2v v1 half over 1 half will become 2v 1 half equals to ln x plus the arbitrary constant c. Now this can be an answer, but we can simplify this further, so it will become 2v 1 half minus ln x equals to c. So this is our final answer. Thank you for watching. I hope to see you again next time.